Yeah, we talked about how when you see, you think. Remember, this worksheet that we passed out, wherever it is, ta-da, is due on Monday. You're supposed to find an answer key and randomly write it out? No, you're supposed to make it your... If I get one that is filled out like an answer key, I'm going to say, nope, no credit, and hand it back and have you do the whole thing over again. Are you supposed to be filling it out from an answer key? No. You're supposed to be looking at forevers, looking at notes, writing down problem-solving strategies, clues, etc., and we've done some of that in class. Why do we go over the answers from one answer key in class? In case you didn't get a blank, in case you put something wrong or incorrect, and in case you like a way that they explained it better than what you put. Does that make sense? So, what you're getting right now is the second part of homework this weekend. The second part of it, wait, calm, breathe in, breathe out. We just, as of today, should have practiced 1 and 2 from a previous year's FRQ collection. There are 6 total on an AP exam. What did I say you could use on 1 and 2 of this AP exam? That we've been working on. We did 1 one night and 2 last night. You can use your calculator. Guess what or which FRQs on Saturday, April 1st you're going to be able to use your calculator on? 1 and 2. Guess which FRQs you're going to be able to use your calculator on the day of the actual AP, which is May 9th-ish? 1 and 2. So guess which ones I want you to practice on these 2016 FRQs? Just 1 and 2. I want you to practice 2 more calculator FRQs after we grade 1, and sadly I wanted to grade 2 today, but oh well, we'll grade it Monday. So 2016 numbers 1 and 2, fully attempted on Monday. Fully attempted on Monday, and yes, you can use your what? Calculator, calculatrice, calculadora. And every time in any FRQ, you'll be given either a table, or functions, or a graph, or just plain words, or some combination of all of the above. All right. Before we go to our when you see, you think, kiddos, did we already do this one yesterday? How to know whether or not F is increasing? I think we did, didn't we? Who did I owe candy to from yesterday? Really? No one? Okay. So, no one wanted their candy from yesterday. Let's start over today. Okay, does someone want their candy from yesterday? I owed like 2 of you.
Kyle probably got candy. Kyle probably got one.
Huh? Okay, go get it. I have peanut butter, and regular M&Ms for those that are chocolatey, and then I have gummy bears for those that are non-chocolatey. So only for those that I owed from yesterday. For today, let's see what else we have. You ready? From randomly who knows where, how can we, or what should we think when we see, find where the slope of f of x is increasing? Noah. No. No. You answered how to answer the question where f is increasing. You're right for this question, but you're wrong for this question. When is the slope increasing? Chris? No. It's still the increasing question, but we don't care about the max or mins per se, because it could be at the max and going down. That doesn't work. Who hasn't answered? Gabby. When the double prime is positive. And Gabby, you can come on down and grab something. To help us when the double prime is positive, wait. Who is the slope of f referring to? F prime. So if it says the slope of f, it's asking when f prime is increasing. We have to look at f prime's prime. And who's f prime's prime? F double prime. Find the critical numbers of f double prime, make a sign chart of f double prime, figure out where f double prime is positive. Is that a when you see, you think?
It should be.
D what? 12? Ooh, better double check you got that one right. D12. If the slope is increasing, that means the first derivative is increasing. And if I were you, I'd put something like, what's the practical application of this? Isn't velocity a first derivative of position? And couldn't a question ask for velocity? Where is velocity increasing or decreasing? Who should you look at to see if velocity is increasing or decreasing? Acceleration, or S double prime. Ooh. All right, something else. Find the minimum. Find the minimum. Noah.
You find the critical numbers.
Good.
Then you get a sign chart.
Good.
And find the value goes from 110.
No, negative, positive,
From
negative.
And you make that into a table and choose the lowest number.
What are you putting in the table besides the critical numbers? Good. So the key was not even necessarily whether you could find that totally counts, whether or not you can find the relative min, which would be f prime going from negative to positive. But if you can just take the critical points, take the endpoints, make a table, and say who is the lowest. What are you plugging into though in the table? X's are the critical numbers and endpoints, but who are you plugging it into? F. You're saying what are your function values, not what are your derivatives, what are your function values. The minimum. Hey, how would we explain the minimum? The means what? Absolute min. Another one. Oh, hey, find the critical numbers, good, good, good. Find the relative min, good, good, good. Plug them in, check with the endpoints, choose the smallest f of x value. Ooh, how do you find critical numbers? Jonathan.
Where f prime of x equals 0 is times 0.
Whoo, you got both of them. That counts. Equals 0 or DNE. If you want to come on down, come on down. Is it right? Pitchfork. If it's a fraction, it's at the top equal to 0 and the bottom. Remember next one. Inflection points. Careful. I'm not saying possible. I'm saying actual. Carla.
I'm gonna try. You find the second derivative and you say equal to 0?
Or.
What?
Equal to 0 or. Just keep going. So after you take the second derivative, set equal to 0, then what?
Is it equal, and then you do the sign chart?
And you're checking for?
Positive and negative.
Yeah, where they change sign. I'll take it. Come on down, Carla. But who can add the one thing she should have?
DNA.
Yep.
Oh.
Remember where it's 0 or DNA. Josh, that counts. Come on down. Should we do one more?
Candy.
Double check. 0 or DNA. Make a sign chart. Make sure the sign changes. Last one. Show that the limit exists. Kyle.
So I think A exists, so take that way. So from limit of x at A from the left is equal to limit of to the right, it's the same equal each other. And f of A exists.
Does that have to be true?
I'm not remembering.
So the only things that have to be true are the one-sided limits that he said, come towards A from below, come towards A from above. The two-sided limits have to agree, but question, kiddos. I don't think it'll let me draw on this. Sad thing. Hold on. Will let me draw on this. My question to you is, if this is A, does the limit exist?
Yes.
Yes.
Ah!
It does exist.
Are the cars meeting?
Yeah.
Everyone should say yes.
Yes, they do.
Is the diner closed or burned down?
Yeah.
Yes. But are they meeting?
Yes.
Now, are they going to have to relocate possibly for breakfast?
Yeah.
Yeah, maybe. But it doesn't matter. Does the limit exist? Yes. Now, does the point exist? That's the what am I talking about if I care about the limit and the point? Yeah, I'm seeing if it's continuous, right? So function value exists, limit exists, do they agree? No. Is this function continuous? No. But does the limit exist? Yes, and it is right there, whatever it is. Okay, double checking. Kiddos, enough candy for today. I mean, never enough candy, but either way. Good for now. We'll see if some of you have been studying your When You See You Things and Forevers on Monday. All right, let's go ahead and check the When You See You Things from C and D. Remember, you can ask me questions. You can look at what this possible answer key says, but do not take it for gospel truth. You can take gospel truth as gospel truth, but not much else. All right, here we go. Raise a hand or call it out. If something automatically hits you kind of funny, maybe you think you have something better or you have a question. Carla.
C4.
Yeah.
I didn't know what to do with it.
This is actually, you know how we were looking at, no, we're going to grade today, FRQ 1A. The one that we're going to grade today, 1A, is a great example of this, where you're given a table of values. They're asking for an approximate rate or an approximate derivative of a point that two other points are straddling. Now, they don't use A and B because A and B are the endpoints. They say, hey, the 2 points straddling are the H and the K, and they just do F of B minus F of A all over B minus A. So long story short, if you guys right now pull out your FRQ, look at number 1 we're reading today, right? Should be right there. Look at A. Are you given a table? Yes. What's the Y value of the table? Velocity. What are they asking for in letter A? Are they saying the exact or are they saying approximate? Or they could be saying average. Whether they're saying average or approximate, either way. Where are they asking for the average or the approximate at? 1.4. Go look in the table. Is there a t equals 1.4? No. But are there 2 points that straddle 1.4? Yes. What are the two t values that straddle it? 1.2 and 1.6. So how do we use those points, the x's and the y's of the 1.2 and 1.6, to help us approximate f of b minus f of a over b minus a? Change in y's over change in x's. Equals is approximate, those squiggle lines, is approximate to the derivative then. Does that make sense? So f prime is approximate to the average. When you have a table, you're looking at 1 point. It's not there, well, that's good, because if it was there, we knew nothing about the rate there. We have to straddle it and take the average.
So is it different from that C4 to C2?
C2 just says in general, when you read average rate of change, use the formula. C4 is saying when they say approximate the derivative in a table, then you're going to be using the average rate to do it. Does that make sense? With the 2 points that straddle. Hey, they use straddle. They're smart. Okay, anything else? Jonathan, you have a question? Or a comment?
I'm just confused on C7 and C8.
Okay. Horizontal tangents. If it's horizontal tangent, that means it's flat. If it's flat, that means the slope is, so m is 0, which means the derivative at a point is 0. So find when the derivative is 0, because that's when the slope is 0. Horizontal line, m is always 0. Vertical line, m is undefined. M will be undefined when it's a number over 0. So we set the denominator of the derivative equal to 0. Does that make sense? So think with pitchforks. When the top is equal to 0 is a horizontal tangent line, the bottom equal to 0 is a vertical tangent line. When they're both equal to 0, kind of both, it's indeterminate. Okay, any other questions? Kyle?
For C5 and C6, is the only difference between them is how you find the slope, right?
Yes,
Okay.
because both of them are lines, both of them use point slope. Both of them have the same point, x1, y1. Just tangent says just derivative, plug in x1. Normal says just derivative, plug in x1, opposite reciprocal.
If we were to put in terms of A and B, would we be able to do that?
Yeah, you could. You could say instead of x1, y1, you can say a and b. So then you would have x minus a, y minus b, and f prime of a.
I'm confused by what I'm putting in C6.
Yeah, so you could have a, you could have b, and then you can have negative 1 over f prime of a. Blue. Okay. Yay. Any other questions on what you see? We need to scroll down some more, right, guys?
Yeah.
Okay, let me scroll down some more. Can you just randomly go select something that's not C? There we go. Did we get all the way to the bottom? How far down do we get? That's good? Okay. You have to go up to C7?
Yeah, I was a little troubling.
Oh, remember, we just talked about this one. For horizontal, Set the top of the derivative or the numerator equal to 0 because the slope is 0. So set the whole derivative equal to 0, but vertical, set the denominator equal to 0.
Oh, okay.
Yeah. Could you guys have just used your forever card on C12? Yeah, you could just use your forever card on C12. C11, if they give you a tangent line, what should you be able to know? The m of the tangent line is the derivative somewhere, and a point of this line will be the same point as the f of x. They're going to share an x and y. Okay.
What's the vertical?
C12 is the derivative of the inverse. So it's when you're given f of a equals b, is that right? If you're trying to find f inverse prime of b. Oh, did I do it backwards?
F inverse prime of A equals 1 over f prime.
Yeah, that works. When f of a equals b, is that right? F of b equals a, f inverse of a equals b. Oh, I don't remember how the forever card goes, but it's that one. Amy. Yeah. C9. Approximate. Oh, C9. It's local linear approximation. And I think, hold on, we talked about that one yesterday. Was it somewhere else? Was it in the B's? Local linear approximation, tangent line approximation? Is it not? I thought we talked about it. Maybe we didn't. No, it wasn't in B. Was it not in A or B? Weird. Huh. Maybe that moment. Maybe it's just from this morning. C9 is the local linear approximation or the tangent line approximation. We talked about this when we did derivative applications right before the end of semester 2. For the tangent line approximation. They're saying you know a point, you know a function. You can make a tangent line at that point using just the tangent line equation. They want you to approximate a function at some other x value that's pretty close to the old x value. You approximate by plugging it into the x spot of the tangent line. So you find the tangent line, you plug in the new x value, and then you solve. But something that some of you guys might not have written, that's a great thing to write down, is if they, because almost always the AP does, they don't just want you to use the tangent line to approximate at an x, they also want you to determine is that an over or under approximation. And the key to answering this question is think about f double prime. Is f double prime positive, concave up? Draw a tangent line. Where would he always be? Below. That's an under approximation. Concave down. Where would the tangent line be? Above. That's an over approximation. So use the tangent line, plug in the new x value, check concavity to know whether the tangent line is below or above based on concave up or concave down. Okay, can I keep going? Oh, Carla, go ahead.
Use numbers that again for C11.
Oh, C11, they're giving you the tangent line approximation, and you're trying to ask yourself, what do you know as a result? If they give you a tangent line approximation, they give you a tangent line equation. The m must be the derivative. So thinking backwards, the m is the derivative, and then this line and this function will share one point. It'll share an x and y. That's usually like something that we'll use to solve for something. They'll share an x and a y. Okay, can I scroll down to D? Alright. Remember, do not write exactly what is up here. Make it your own. If I see yours looking like an answer key all the way throughout, I will say no good, start again. That's fair. I just give it back to you and say, well great, you can use this, but now make it your own. I'd be tempted to, but I'm like, well then you don't have to go look at videos, you have something to use, just can't. Oh, D3. Relative extrema. C3, you better have two ways of solving because the AP sometimes forces your hand. For relative extrema, you have to find critical numbers, F prime pitchfork. And then either use a sign chart with the first derivative test for relative extrema, or plug into the second derivative, checking the concavity to see whether maximum for concave down or minimum for concave up. But you must find the critical points first, then test on the sign chart or concavity. Could the AP force you to use the second derivative because that's all they give you? Yes. So you have to know both tests. Any other questions on what you see? John? D6. Well, not my favorite ones, to be totally honest. But to find the range of a function on negative infinity to infinity, basically we just find the relative extrema, and then we take limits to infinities. So you can think of a sign chart. So if the sign chart, for instance, shows increasing then decreasing, we can know the max of the range, and we know the mid is negative infinity. So you can kind of tell from the sign chart. That's why they say think about limits to infinity and negative infinity, but I would also say think about relative extrema and sign charts. Just think 14 identifies, we can know how a graph is moving and changing based on that. D7 says closed interval. I would say test for absolute so critical numbers and endpoints. So I'd actually just on D7 just go back to the absolute extrema wherever. D5. For the closed interval, just think about the endpoints and the relative, and the critical numbers. So D7, I would say look at D5, DC, D6, blah, blah, blah. Take the limits to infinities to think about the sign charts, what's going on. Yeah. Oh, it's supposed to say switches. Inflection points. In your forever card, you better be relating this to actual inflection points. Actual inflection points, the pips, and check for a sign change on the sign chart that Carla said earlier today. Good catch, though. I know. Switches, not witches. Okay, anything else? You need to scroll down a bit. Is that it? Oh, still default B13. Okay, that's it. Last questions. Go ahead and check. I'm stealing some peanut butter M&Ms just cause. How about now? Eileen. D13. Woo! That's exactly like the when you see you think we started with today. How do we find a minimum slope? How do we find a minimum derivative? Look to the second derivative, zeros and dn's. And then test with the critical numbers and endpoints, but of the second derivative. So I would go ahead and say slope of or rate of, put a little slope of and say rate of, and then put a little roll and say f prime. To find the minimum of f prime, you have to look to f double prime. All right, almost there. Anything else? How are you guys doing? Do you think you're reviewing by filling this stuff in? Do you think you're also being shown or introduced to different types of AP problems? Mm-hmm. As soon as you're ready, FRQ number 1 in the color pen. As soon as you're ready, FRQ number 1 in the color pen. If you did not fill anything out, I don't care. Put your name on it, and you're switching with someone. And they're going to give you the, seriously, the 0 out of 9 score. D13. Oh, this is the one Eileen just asked about. Minimum slope is minimum rate is minimum derivative. We look to second derivative. Does that make sense? Exactly. That's the one that I thought. Yeah, D11, just say look to see the one you asked about. Yeah. All right, switch. I don't care. Someone in your group, someone close. Switch all the way around. No one is allowed to have their own. If it's blank, I don't care. Put your name on it and pass it. You're not allowed to sign your own paper. Andy, where's yours? I don't care. Pass it to Cameron. Put your name on it. Number 1. Get a color pen.
This D is making this feel weird.
Well, you need to have done your homework. It was due yesterday. The point is to try. I don't want that to be what your AP test looks like. You tracking?
Mm-hmm.
Okay, good.
I feel like it's gonna work because
But you have time now. You got to use it well. Kiddos, we're going to go fast. At the end of the day, sign your name at the bottom of the FRQ you have. Sign your name right now. If you turn in an FRQ and it has no sign name at the bottom, I know you didn't have it done on time. You didn't even switch it with someone. Sign at the bottom, the one that you're grading. Everyone right now should have a color pen in their hand. All right, here we go. On the very, very top, underneath the name, put a little slash fraction bar and then put a 9 in the bottom. You're going to give them a score out of 9. If they have nothing written, put a 0 right there. That is what you would get on an AP if you didn't write anything down. But I'll show you how you could have at least written a few things down and gotten at least 1 or 2 points. For letter A, you were allowed to get 2 points total. If they have both of these exactly right and they didn't make it wrong, you're allowed to put a check over a place that indicates, hey, you were right. However many checks you have at the end or how many points they get. Now wait, pause. 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 Don't put anything in. Look. Pause. No checks. Eyes on me. The approximation says they knew to do v of 1.6 minus v of 1.2 over 1.6, 1.2. Technically, as I've taught you, you all should have this if you got it right, and it should be boxed. Why?
Because
You could have made that wrong. Why are there only 2 decimal places? The third one would have been a 0. If they have this expression, and A, they either got that right, or B, they didn't get that at all, then you may put a check. If they wrote this and they got that wrong, there is no check, there is an X, they made it wrong, even if they started with it right. Give them a check if they wrote this right and got that right, or just wrote that, and long story short, if they tried to solve and got it wrong, put an X and no check. But they could have stopped here. That's one check. What's the other check for? Either miles per hour squared, or mph over hours, or miles per hour per hour. All of those units would have gotten a check. If they did any other units, put an X. People who didn't write anything, you could have at least gotten a point for units if you had thought about it. Okay, how many checks could you possibly have put in the first one? 2. If they made something wrong, do they get that check?
No.
Cross it out and put an X. If you make it wrong, even if you had it right to begin with, it's wrong. Where do I want you guys stopping? Right here. Box it and be done. Letter B. You get 1 check mark for writing total distance traveled and having miles in your answer. You could have written miles here, you could have put miles there. If they put total distance traveled, technically they should have put from 0 to 2.4 minutes. Hours, sorry. From 0 to 2.4 hours. Read the problem. It says, using units, explain the meaning of, or interpret the meaning of. 1 point is for saying total distance traveled from 0 to 2.4 hours, and they had to put miles somewhere. If they didn't put miles anywhere, they don't get that point, even if they said total distance traveled. Total distance traveled using miles. They get a point. Watch. They get a check if they used 11.8, 17.2, and 16.8. If they knew to use the middle y value for the midpoint. Midpoint Riemann, if they use 11.8, 17.2, and 16.8, they get the second check. And if they wrote the entire, or have an expression for the entire area, multiplying each of those by 0.8, they could have just boxed it. That would be the third check. If they have this and they got that wrong, they don't get that check, they get an X instead. One more time. Check for total distance traveled with miles. Check for using the middle y's, 11.8, 17.2, and 16.8. And a check for having a correct expression they did not make wrong for the answer. Letter C.
How about if I was if there's a 0?
Oh, you can have 36.640. You don't have to write the 0. That's the only time you don't have to write 3 decimal places, is if it would be a 0. At the end, you can leave it off. Letter C. You get 1 point for writing the integral correctly. Now pause and watch. They could have written 1 over 2.4 minus 0, integral from 0 to 2.4 of g of t dt. They could have plugged in g of t dt, but watch. If they plugged in g of t, make sure they wrote it correctly. If they wrote it incorrectly, you have to give them an x instead. But if they wrote g of t, they're fine, and if they wrote it, copied it down correctly, they're fine. You do not have to write everything on a calculator FRQ. You're not solving, you're plugging it in. And then if they got, second check mark, if they got 14.064 miles per hour, if they didn't put miles per hour, they don't get that check. If they rounded to the second or the first or the whole number, they get it wrong. They only get it right if they have units and they rounded 0.064. They could have more, but they have to have 0.64. Were there any other decimal places past that? Did anybody write anymore? Just 0.64? Okay. Technically, if it's 0.639, they could have also had 0.63. That would have also been appropriate.
What about you forgot the dt?
Mark it wrong. If you make it wrong, they will. Sadly, they'll like, oh, what were you thinking?
That's
They'd be sad for you. They'll be sympathetic, but they'll think it up. Chris.
So like they put they wrote in GDT, but they don't write GFT. They actually wrote in.
If they wrote it in, and if you check the top, and if it's correct, if they wrote it in right, you can give them the check. If they changed anything in how they wrote it,
No DFT.
no DT, that's wrong. Ah, you guys kill me. Good thing it's not the actual AP. Good thing it's not the final exam AP. Learn. Letter D. Letter D. Pause. Listen. I will let you give them a check mark if they got speed is increasing. But to get the second check mark, they have to say, because velocity and acceleration are both positive, have the same sign, agree in their sign, they have to state what our forever card says. Speed only increases when velocity and acceleration are the same sign. Or both positive indicates same sign. One check for speed is increasing, one check for because they have the same sign. Give them, how many check marks do you count? Out of 9? Give it back to them, and guys, I'll let you see the answer key for a couple seconds with your own FRQ. If you want to write yourself any reminders, highlight something and say, oh my goodness, don't you forget. Give yourself some pointers in a color pen, not in a pencil. And if you did not do it,
You got it.
you are going to do it before Monday.
Should I write like do a shoot miles squared per hour? Shoot, I need to change that.
Technically, anything you do now is correction, so it should be done in red pen.
If I do it wrong, then
All right, we'll hand this in with number 2 on Monday. Once we grade number 2, write yourself little notes. I'll leave this up here for like 2 more seconds.
to be so specific.
Really quickly, grab out your calculators. I want you guys to help me answer the question. How could you do this without solving anything? How could you find the acceleration? Get out your calculators. It's right here, Joyce. Right here. All right, for letter D. Kiddos, whenever you see something like this, what this says is it could have been done in your calculator. How? What is the function for G? Okay, hold on. Why am I going to math? And why am I going to something called n derive? It takes the derivative at a value. This does not find the derivative equation in terms of x or t or m. This finds you a number. DDX, question, who is my function? I mean literally, I don't have it memorized. Who's G of T?
24.
All over. Where are we trying to find the derivative at when we were thinking about acceleration in the last part of the FRQ? 1.3. Now, you needed to know speed increasing or decreasing. You have to check velocity and acceleration. But kiddos, couldn't I have said, yay, go? And it told me, oh, hey, there he is. Look, he's positive. Yay, go team. And couldn't you have put this in y1 and done y1 up for the first one and then done the derivative of y1 for the second one? Use that calculator. All right, kiddos, put this FRQ away. You're turning it in with number 2 after number 2 gets graded on Monday. We need to do at least a little bit of practice today. Here we go. Back of your spirals or composition books open wherever we left off earlier. We need to practice some NVT. Don't have tons of time, but we have a bit. Where did we leave off? Yes. Oh, we did not get very far. Number 7. Is this where we left off?
Yeah.
Okay. Back of your spirals or composition books, wherever we left off. Multiple choice practice. I think the topic is still continuity. What, John?
Yeah, we passed.
Oh, I don't have an answer on it.
You did like that 3
All right, never mind. So we got, I thought we did this one. That's A, right?
We're on the previous 10. No, we're on 10.
Nice, mean value theorem.
I think we saw this one. We did this one also. Yeah.
Oh yeah, we talked about continuous, and then we talked about how it looks like rolls, but what was missing? Differentiable was missing. All right. Number 11, kiddos. Number 11, if you guys notice, I'm just continuing the numbering from day to day to day, from section to section. So you could, in your when you see, you thinks, if you see a problem that shows the topic in when you see, couldn't you kind of say MC number whatever to go look at? Just saying. Okay, number 11. What do we know? Tell me the words you should be writing down right now to summarize these directions. Continuous.
2, 4.
Okay, on an interval. 2, 4. What else?
F double prime.
Good. Twice differentiable, so F double prime exists. What else?
F prime with 3.
All right. F prime of 3 equals 2 means the rate at 3, right? The rate or slope at 3 is 2. What else do we know? We know that then the function is, what is F doing at 3? What do we know from this F double prime? F is concave down, which means F prime is decreasing, or the rate is decreasing, right? And actually, it says on the interval, so it's not even just to x equals 3. Okay, so we know F is increasing. It's increasing at a slower and slower rate, and at 3, I need to somehow see a rate of 2. Ugh. Does anybody see something that we could automatically cancel out? Why can we cancel out D and say, no way, Jose? F is increasing, but at the same rate. We know the rate needs to be decreasing. It's increasing by smaller amounts. What can we do with E then? Isn't that increasing by bigger amounts? So let's look at the other 3. This one's going up by 2.5 and then by 1.5. This one's going up by 2.5 and 2. This one's going up by 2 and then 1.5. Aw, stink. They're all increasing at decreasing rates. That's the key. At 3, the rate is 2. Which one is the only one that makes sense for the rate to possibly be, if it's strictly decreasing, to possibly be 2 at 3? No? A. Why? In between 2 and 3, the average rate is going to be the instantaneous rate somewhere between 2 and 3. And then between 3 and 4, the rate's going to be 1.5. Is it good if the rate's supposed to be 2 at 3? Is it good if it's 2 over 3 to 4? Nope, that's saying it's 2 somewhere in between 3 and 4, not at 3. And in this one, is it good if I have 2 being between 2 and 3? Nope, the rate's at 3. Therefore, these ones say nope and nope. That one was really hard. That one was really hard. Just a heads up. That one was really hard. Okay, let's go find an easier one. How about, let's do this one, number 13. What do you guys notice about the answers that might give you some hope? Decimals, it's a calculator problem. Kiddos, how can we use our calculator to its fullest extent? What do we know? F of x equals x plus ln of x. When you see instantaneous rate of change, what do you think? Hey, where are you? When you see instantaneous rate of change, what do you think? Derivative. So, for which value is the instantaneous rate of change the same as what? Well, this isn't bad, is it, guys? Can I actually do this in my calculator? Oh, that's cool. Let's plug our function into our calculator into y1, right? My function is x plus ln of x. X plus ln of x. What do I need to use this function for, kiddos? Why am I going to the home screen and hitting the fraction-y button? Yeah, I use them for average value, right? So can't I do alpha trace or vars over function y vars? y1 of b minus y1 of a all over b minus a? And can I get my average value to be 1.46209? Why am I not rounding it? Why am I going to stow them? Because I don't want to round them. I want to use them. Who needs to be equal to that? The derivative. Wait a minute. Do I know what c is? Nope. So what do I have to do? Take it myself. Oh, that was a struggle. Whew. Derivative of x is 1. Derivative ln of x is 1 over x. How do I do this in my calculator? How do I take two different, wait, pause, sides and set them equal? Can't I be super spiffy and say, wait, can't I just graph them both and look for an intersection? Wouldn't that be cool? Couldn't I say, hey, look, there's one, hey, look, there's another, and hey, look. Can't I actually even make my window to be snazzy and be 1 to 4? And what am I looking for? An intersection. I see it. Do you? Real quick, this and then this and then this, and we're going to say intersection, please. First curve, second curve, intersection. Is that an answer? Bye, cool kids. I'll see you Monday. We got some more practice to do, but keep on working on your when you see you thinks. FRQ 1 and 2 should have already been done by today, so do 216, 1 and 2 with your calculator, calculatrice, calculadora. Over and out. Yes, in the front, in the pile, and that just go down like a stack of chicken.